this lesson, we are going to talk about solving rational equations. So when we're solving, we need to be aware of what is in our denominators. So I have a variable in the denominator on number 1, and I need to get rid of that x plus 4. So we've talked about in previous lessons how you identify your least common denominator, and so you're going to use that to figure out what you need to multiply by to get rid of that denominator. So I also need to keep in the back of my mind what x cannot be. So I know that if I were to take and plug a -4 in right here, -4 plus 4 would give me 0. So in the end, if I solve and I get an x value of -4, that would be considered an extraneous solution. And we will have some of those examples. So I need to multiply everything by x plus 4. So I'm going to take x plus 4 and multiply it times the 1 over x plus 4. And then also take that 2 times the x plus 4. So every term that I have gets multiplied by x plus 4. So since I'm dividing by x plus 4 and then I multiplied by x plus 4, that is going to cancel, leaving me with 1 equals, and then I need to distribute, so 2 times x is 2x, and 2 times 4 is 8. And now I just solve for x, so I'm going to subtract 8. That gives me 2x is equal to -7, divide by 2, and so x is equal to -7 halves. Now remember, the only x value that would be excluded would be -4, so this x value is fine. So if I look at number 2, the only factor I have in a denominator is x minus 3, so I'm going to multiply every term I have by x minus 3. So I'm going to take the 1 over x minus 3 times the x minus 3, and I'm going to take the 5 times x minus 3. So the x minus 3 will cancel, leaving me with 1 is equal to, I'm going to distribute this 5, so 5x minus 15, and then I'm going to solve. So I add 15, so I have 16 is equal to 5x, divide by 5, that doesn't reduce, so x is equal to 16/5. And remember, you're going to keep in mind, what can x not be? X cannot be 3, because 3 minus 3 would give me a 0. All right, number 3. The only thing I have in the denominator is x plus 5, so I'm going to multiply everything by x plus 5. So I have x plus 5 times 2 over x plus 5, and x plus 5 times 4. So the x plus 5s will cancel, leaving me with 2 equals, and then I'll distribute. So I have 4x plus 20, and then I solve. So I'll subtract 20. So I have 4x is equal to -18, divide by 4, and x is -9 halves. Make sure you reduce there. The only thing that x could not be was -5. All right, and on this one, I'll be multiplying by the x minus 7. So I have x minus 7 over 1 times x minus 7 is equal to x minus 7 times 2. X minus 7 will cancel, leaving me with 1 equals, distribute this 2. That gives me 2x minus 14. And then I'm just going to solve for x by adding 14. So I have 2x is equal to 15, divide by 2. So x is 15 over 2. The only thing that x could not be was 7. All right. Arthur and Cheyenne are making Chinese paper cutting designs to give as gifts to wish family and friends good luck in the coming year. Together, they can complete the job in 24 hours. Cheyenne works twice as fast as Arthur. How long would it take Cheyenne to complete the job if she was working alone? All right, so let's talk about Arthur first. So we have Arthur, and we know that Arthur can complete one job in X amount of hours. Now, I don't really want to have this in terms of hours that I don't know. So we're going to convert this into jobs per hour, 1 hour. So we're going to think of this x as being over 1, and we're going to do like a fraction within a fraction. So we're going to keep the 1 on top, times it by the reciprocal of the bottom, and that would give us 1 over x jobs per 1 hour. So we know he can do 1 over x jobs in 1 hour. All right, so let's talk about Cheyenne. They tell us that Cheyenne can work twice as fast. So she can do 1 job. Instead of X amount of hours, that would be X amount of hours divided by 2 in half the time because she works twice as fast. All right, so I'm going to keep my 1 on top times and then flip my bottom. So that gives me 2 over X jobs in 1 hour. All right, now their work time together, we need that as well. So their work time together is that they can complete 1 job in 24 hours. But again, I don't want this in 24 hours. I want it in 1. So I'm going to think of this as 24 over 1. So I can do 1 times 1 over 24. So I know they can do 1/24 of a job in 1 hour. So if I take his work time plus her work time, that should equal their total work time. So I have 1 over x plus 2 over x is equal to 1 over 24. Now I can set all those equal because we literally made them all per 1 hour. All right, now I'm trying to solve. I see that I have a common factor of x on bottom, and then they have a leftover of 24. So my least common denominator is 24x. If I multiply by x, that will get rid of all of the factors of x on the bottom. If I multiply by 24, that gets rid of the factor of 24 on the bottom. So I am going to take 24x and multiply it times 1 over x. I'm going to take 24x and multiply it times 2 over x. And I'm going to take 24x and multiply it times 1 over 24. So my x's will cancel, and now I have 24 times 1 is 24. My x's cancel again. 24 times 2 is 48. And my 24 cancels, leaving me with x times 1, which is x. And so if I put together the 24 and the 48, that gives me 72. And x represents our hours. So this is 72 hours. Now we have to know, who is this for? Well, I already know that Arthur can complete 1 job in X hours. Well, that would be 72. So it takes 72 hours for Arthur to do 1 job. But they said Cheyenne works twice as fast. So that means we can cut that 72 in half, and that gives us 36. So Cheyenne can complete this job in 36 hours by herself. Now, if you take a look at number 6, it's almost exactly the same, except now we're talking about filling up a pool. So it takes 12 hours to fill up the pool with 2 pipes. So instead of having 2 people who are working together, we have 2 pipes that are working together. All right, the water in one pipe flows 3 times as fast as the other pipe. How long will it take the slower pipe to fill the pool by itself? So we could say, well, 1 over x plus, instead of being twice as fast, it's 3 times as fast. So 3 over x equals 1 over 12. So this time I need to multiply by 12x. So I'm going to multiply 12x times 1 over x. 12x times 3 over x, and 12x times 1 over 12. So my x's cancel, and I have 12 plus x's cancel. 12 times 3 is 36 equals 12's cancel. X times 1 is x. So x is equal to 48. Now we have to think about this. It says, how long will it take the slower pipe to fill the pool by itself? This would represent the slower pipe, so I can do that 1 job in 48 hours. Now, if it asked me about the fast pipe, then I would divide that by 3 to get my answer. All right, so now we're going to solve some that have more than one factor on the bottom. So I see that I have a factor of x minus 5, a factor of x minus 3, but this is not in its factored state. So we're going to put it in its factored state. So we have 2 minus signs. And what multiplies to make 15 that adds to make 8 is 5 and 3. So I see that I have a common factor of x minus 5 among all my denominators, and I have a common factor of x minus 3, and then there's nothing less. So my least common denominator would be x minus 5, x minus 3. In other words, to get rid of the x minus 5 on the bottom, I multiply every term by x minus 5. To get rid of the x minus 3 on the bottom, I multiply everything by x minus 3. So I'm going to go through here, and I'm going to multiply by x minus 5, x minus 3 times 1 over x minus 5, plus, and then I do the same thing for the second term, x minus 5 times x minus 3 times x over x minus 3 equals, and then again on this side, x minus 5 times x minus 3 times 2 over x minus 5 times x minus 3. So I just took the x minus 5 and the x minus 3 and multiplied it times the first term, the second term, and then this third term over here. Now I simplify. So I see that my x minus 5s will cancel, and I have 1 times x minus 3, which would just give me x minus 3. My x minus 3s cancel, so now I have x times x minus 5. So that would be x times x is x squared, and x times negative 5 is negative 5x. And then I have my equal sign, and then the x minus 5 will cancel with the x minus 3, and that is equal to 2. Now that I've eliminated all of the denominators, I need to solve for x. So I notice that I have an x squared, I have some x's, I have some constants. So I'm going to assume that I will probably be factoring this. So I'm going to get everything on one side, combine like terms. So I only have one of this x squared, and then I have a 1x and a negative 5x. That makes negative 4x. Please do not do the inverse and add, like 5x to the 1x. They're on the same side, so just combine them. But I do need to move this 2 over, so I'm going to subtract 2. So I have negative 3 and negative 2, which make negative 5. And then I do have this trinomial that I'm going to factor. So I have a positive and a negative, and what multiplies to make 5 that subtracts to make 4 is 5 and 1. And since I need that middle term to be negative, 5 will be with the negative and 1 will be with the positive. Then I'm going to set those equal to 0, and I'm going to solve. That gives me negative 1 and positive 5. Now I need to look at those answers and consider what x can't be. So I already know that because I have x minus 5, x cannot be 5 because 5 minus 5 would give me a 0 in my denominator. I also know that I have x minus 3, so x cannot be 3 because 3 minus 3 is 0. So because I got an answer of 5, that 5 is considered an extraneous solution. So the only valid answer I have is negative 1. All right, on number 8, everything is already factored out. So I see that I have a common factor among the bottom of x plus 2 and x minus 2. So I'm going to multiply by x plus 2 and x minus 2 on every term. So we have x plus 2, x minus 2 times 1 over x plus 2 plus, and then again, x plus 2, x minus 2 times my second term, which is 1 over x minus 2 equals, and then x plus 2, x minus 2 times 4 over x x plus 2, x minus 2. So I notice on the first term, my x plus 2 will cancel, and I'm left with 1 times x minus 2, which is just x minus 2. X minus 2 cancels, leaving me with x plus 2 times 1, which is just x plus 2. And then both of these terms will cancel, or factors, I'm sorry, will cancel, leaving you with 4. I don't have any x squareds, so I'm probably not going to end up having to factor. I have a 1x and a 1x, that's 2x. The negative 2, positive 2 cancel, that equals 4. And then I solve by dividing by 2. So I get 2 as an answer, but if I'm looking up here, x cannot be 2 because 2 minus 2 would give me a 0 in the denominator. And therefore, since this is the only answer I have and that answer is extraneous, this has no solution. All right, number 9, the only factor I have in the bottom is x minus 2. So I'm going to multiply x minus 2 times every term that I have. So x minus 2 times 5x over x minus 2 equals, and then x minus 2 times 7 plus, and then x minus 2 times 10 over x minus 2. So the x minus 2 cancels, leaving me with 5x equals, I need to distribute this 7. 7 times x is 7x, and 7 times negative 2 is negative 14. X minus 2 cancels, and I have plus 10. So now I'm just going to get everything together and solve. So I'm going to subtract this 7x to move it over here to the other side with the 5x. That gives me negative 2x equals negative 10, or negative 14 and positive 10 make negative 4. And then we'll divide by negative 2. So x is 2. But if I look up at my original problem, x cannot be 2 because 2 minus 2 gives me 0 in my denominator. So that's an extraneous solution, and there's no other solution. So this is a no solution problem. All right, number 10, I see that I have x minus 3 in the denominator, and I have 4. I also have this minus, and I'm going to take care of that by making it a positive and distributing it through the numerator of the fraction behind it. So I need to multiply everything times 4 and x minus 3. Now, just for extra info, if this wasn't here, let's say this was 2, I would still only multiply by 4 and x minus 3. That's because 2 and 4 have a common factor of 2, and the smallest number that 2 and 4 both go into is 4. So even if I had multiplied this by 4, it would still cancel with the 2 on the bottom. And so just an extra tidbit of information there. All right, so I have my 4 times x minus 3 times 3 over x minus 3 equals, and then 4 times x minus 3 times my x over x minus 3 plus, and then 4 times x minus 3 times the negative x over 4. So x minus 3 will cancel, and I have 4 times 3 is 12. X minus 3 will cancel. I have 4 times x is 4x. And 4 will cancel, and I'll distribute this negative x, so that gives me negative x squared. And negative x times negative 3 is positive 3x. Now, I see again that I have some x's, I have an x squared, and I have a constant, so I'm going to assume that I will be factoring, and I don't want my x squared to be negative, so I'm going to go ahead and add x squared to the left side. And then I have a 4x and a 3x, that makes 7x on this side, so I'm going to go ahead and subtract that 7x to move it to the left. So I have x squared minus 7x plus 12 equals 0. And I'm going to factor that. So we have 2 minus signs. And what multiplies to make 12 that adds to make 7 is 4 and 3. So I'm going to set those equal to 0 and solve, which gives me 4 and 3. Now I have to take into account that I may have an extraneous solution. If I look at my original problem, x cannot be 3 because 3 minus 3 gives me a 0 on the denominator. So 3 is an extraneous solution and 4 is my only valid solution. Paddling with the current in a river, Jake traveled 16 miles. Even though he paddled upstream for an hour longer than the amount of time he paddled downstream, Jake could only travel 6 miles against the current. In still water, Jake paddles at a rate of 5 miles per hour. What is the speed of the current in the river? So when you're traveling with the current, you'll be going faster. When you're traveling against the current or upstream, you'll be traveling slower than you would be in like still water. All right, so we know that distance is equal to the rate times the time. All right, and I do know that he traveled for an hour longer than the amount of time he paddled downstream when he was going upstream. So I'm going to solve for time because I need to make an equation and I know about time. So I need to use distance over my rate of speed. Well, I know that he traveled 16 miles at a rate of, still water would be 5, and he's going with the current, so we're going to add the river's current to that. So 16 over 5 plus c. Plus, he spent an hour longer than he did going downstream, and that is equal to his amount going upstream. So he went 6 miles, and it would be 5 miles an hour in still water minus the current. So now I have an equation, and I have a 5 minus c on the bottom, and I have a 5 plus c, so I will multiply everything by 5 plus c and 5 minus c. So I have that times 16 over 5 plus c plus 5 plus c times 5 minus c times 1 equals 5 plus c times 5 minus c times the 6 over 5 minus c. So the 5 plus c cancels, and I'm left with 5 minus c times 16. So 16 times 5 is 80, and 16 times negative c is negative 16c. Then I have all of this times 1, so it will just be whatever this is multiplied. These are conjugates, which means it will be the front multiplied and the back multiplied. The two middle terms that we normally have there will cancel because they're going to be opposites. So we have 5 times 5 is 25, and then you have a negative 5c and a positive 5c. Those cancel. C times negative c is negative c squared, and that's equal to 5 minus c cancels, and we take 6 times 5 plus c, which would be 30 plus 6c. I do see that I have a squared term. I have some terms with just a c and some constants. So I am going to combine things, and I'm probably going to have to factor. So I don't want my c squared to be negative, so I'm going to add that to this side. I'm also going to add my 16c to the 6c. And then I have an 80 and a 25. That's 105. So I'm going to subtract 105. So now everything is gone from this side. And I have c squared plus 22c minus 75 equals 0. I'm going to factor. So I get c plus, c minus. And what multiplies to make 75 that will add to make the 22 is 25 and 3. And I need 25 to be positive and 3 to be negative. So I set those equal to 0 and solve. And I get a current of negative 25 and a current of positive 3. So it doesn't make sense to have a negative current. So I know that my current was 3 miles per hour.